Hello everyone, this is Dr. A. Chaitanya Krishna. Welcome to Cynohub. Here in this video, we are going to explain about the Biot-Savart's law. This Biot-Savart's law is a basic law for the magnetostatic fields. As well as in electrostatic fields, what are the Coulomb's law is there. Same like that here Biot-Savart's law is the basic law of magnetostatic fields. In this one, the Biot-Savart's law states that we have to find the magnetic field intensity at point P, intensity at point P that is directly proportional to the current element. The current element means whatever the current passing through that line, that will total current we will given as a I into dl. Here current passing through element, the dh is directly proportional to current element, and the directly proportional to the magnetic field intensity is directly proportional to the angle between the point and dl element. That is the sin alpha. That is also directly proportional to the magnetic field intensity. After that, this direct magnetic field intensity is inversely proportional to the square of distance between the P and dl. This is combinedly we can write as a Biot-Savart's law. dh is directly proportional to ideal sin alpha by r square. After that we have to write as any equation. We have to write one constant value. This constant value as proportionality constant dh is equal to k into ideal sin alpha by r square. For this magnetostatic field, this proportionality constant equal to 1 by 4 pi. That's why equation becomes as a dh is equal to ideal sin alpha by 4 pi r square. When we can apply any vectors in this equation, to this equation, this becomes as a I dl cross r bar. Why? Because whenever the sin alpha will come, we can write as a cross product of a whatever the distance is there. That's why dl cross r bar by 4 pi r square, that will given as a dl sin alpha. And this r bar is a unit vector in r direction. That unit vector in r direction means ar bar or r bar dl cross r bar by 4 pi r square. Here this is the for line current, as well as whatever the continuous charge distributions are there for the line charge, surface charge and volume charge. In this magnetostatic fields also continuous current distributions are there. Whenever we can talk about the electrostatic fields, then we will call as a charge distributions are there. Whenever we can call as a magnetostatic field, we have the current distributions are there for line current, surface current and volume current. Current densities are there, I and K and J. Now here after this one, this Biot-Savart's law, for this continuous current elements, we have to find the continuous current elements for the infinite line current. We have to find by using this Biot-Savart's law. What is the magnetic field intensity when we can take an as a infinite line current distribution. Infinite line current distribution, we have to take an as a one finite line is there for A to B. Then we can find the finite line. After that we can apply the infinite line conditions, then we will get as a infinite line current distribution. For that one, we have the point H is there. This we have to find the magnetic field intensity at this point, and we have to take an as a line element is the current element is a dl dash, and the distance is a r. According to Biot-Savart's law, the distance is r, and here we have taken as a line is a to B is a line, up to dl the distance is z, and here the angle is alpha 2, here the angle is alpha 1, here the alpha. Why? Because we have to find only the line current on this, whatever the magnetic field intensity we have to find at this point based upon this line only from A to B. That's why only we have to write it is a alpha 1 and alpha 2. Whatever the equations are there, that equations we can convert into the limits from alpha 1 to alpha 2. Now here based upon this equation, we have to write in this form for line current. That's why here from this diagram we can write as a dl is equal to dz az bar. dl is equal to dz az bar. Why? Because here the dl element is the differential element, that's why we can write as a dz az bar, and r bar is equal to the distance between these two elements, we can write as a rho into a rho bar plus rho into a rho bar minus rho into a rho bar minus dz az bar. Why? Because this direction r is equal to rho and z direction, that's why we can write as a rho and dz direction, rho and dz direction. Or we can write as a, in the z direction the element is z, that's why we can write as a total element is a z, that's why here z into az bar. Here differential element at this point, that's why we can write as a dz az bar. There is no confusion, in the z direction to total z element is a z and differential element is a dz. Now here based upon this one we have to find the dl cross r bar is equal to dl cross r bar is equal to rho into dz a phi bar, rho into dz a phi bar, means whatever the magnetic field intensity we have to find in the phi direction, this value is rho into dz, rho into dz. Based upon this diagram, the z is equal to, based upon this diagram the z is equal to, we have to write as a cot alpha. What is the cot alpha? In between this one and tan alpha. Tan alpha is rho by z. Tan alpha is rho by z. Here tan alpha is equal to rho by z. Then we have to write as a z is equal to rho by tan alpha. Then we have to write as a rho tan alpha 1 by tan alpha, we can write as a cot alpha. Then what is the dz value? Dz value we have to write. What is the dz value? Cot alpha, integration of cot alpha, differentiation of cot alpha is equal to the minus rho cosecant square alpha, minus cosecant square alpha. That value is minus rho cosecant square alpha, that is dz value. Now here we have to substitute all this value. R is equal to, also we can write as a r equal to magnitude of r equal to under root of rho square plus z square. This also we can write as a r is equal to in terms of rho, r is equal to in terms of rho. In terms of rho we can write as a rho cosecant. Why? Because the sin alpha is equal to rho by r, sin alpha is equal to rho by r is equal to rho cosecant alpha, r is equal to rho cosecant alpha. That we have to write all these things in this equation. All these things in this equation, dh is equal to I into dl cross r bar by 4 pi r square. Now here current element I is there, dl cross r is equal to rho into dz in a phi bar, and z is equal to minus rho cosecant square alpha. That's why we can write as a equation is rho square cosecant square alpha. Here we can write as a minus cosecant square alpha into d alpha divided by 4 pi into r square. The r square value is rho square cosecant square alpha, rho square cosecant square alpha. Cot alpha is equal to not cosecant square, that is cosecant alpha. Here we can write as a rho square cosecant alpha, here cosecant square alpha, rho cosecant square alpha. Here this term should be a cancel, and here h is equal to minus I by 4 pi. Here the cosecant alpha is there. This should be also cancelled. This we will get as a cosecant alpha. 1 by cosecant alpha is sin alpha d alpha, alpha 1 to alpha 2. alpha 1 to alpha 2, we have to get it, and we have to write, after integration we have to write the equation h is equal to I by 4 pi and dz. Here we can write as a one row only. Here we can given as a, here the row square. Here we can given as a I by 4 pi rho, I by 4 pi rho, and here sign integration is minus cos. Sign integration is minus cos. That's why minus cancel. Cos alpha 2 minus cos alpha 1. This is the line current distribution. If we can apply the infinite conditions for infinite line, alpha 1 is equal to 180 degrees, alpha 2 is equal to 0 degrees, a is equal to 0 comma 0 comma minus infinity, b is equal to 0 comma 0 comma infinity. Means this along the z axis minus infinity to plus infinity we will given. This condition should be satisfied for the infinite line current distribution. Infinite line current distribution. That's why we can apply the alpha 2 is equal to 0, alpha 1 is equal to 180 degrees. Then we have to get it as a, then we have to get this equation is becomes as a h is equal to I by 2 pi rho. Why? Because this value is 1, cos 180 degrees is minus 1, minus into minus plus. That's why here we have to get it as a, in this, in which direction we have to get, this direction is a5 bar direction. That's why this is also we will get as a a5 bar direction. Here also we will get as a a5 bar direction. Here also we will write as a a5 bar direction. The resultant will be a5 bar direction. Whenever the infinite line current distribution, the h is equal to I by 2 pi rho a5 bar. This is the end of the Biot-Savart's law and for infinite line current distribution. Infinite line current distribution. In coming videos, we have to deal with the other topics of the electromagnetic fields and waves. Thank you.